Last section of the chapter, ladies and gentlemen. This is 5-7, the binomial theorem. This is another shortcut method to expand multiplying binomials. So, like for example, if you were going to have to multiply x plus 2 to the power of 4, currently you'd have to do x plus 2 times x plus 2 times x plus 2 times x plus 2. So you'd have to multiply two binomials, get the answer, get that answer, multiply it by the third binomial, get that answer, multiply that by the next binomial. Woo! But if you actually look, there's a pattern here, right? You can see these numbers. If you take a plus b to the power of 0, you end up with a coefficient only of 1. All right, so you take it to the power of 1, you have 1a, 1b. Take it to the power of 2, look at your coefficients. They go 1, 2, 1. Take it to the power of 3, they go 1, 3, 3, 1. Power of 4, 1, 4, 6, 4, 1. There is a pattern here that you can use to find out what the coefficients are and what would the variables be also. So look, there's a pattern. So how you get this pattern, you start with 1 and you start with 1s here. Then you take the hexagons that are above and add them together. So you always have 1s out here on the outs. Right? So you can go ahead and fill those in. So then to figure out here, I take the edges that are in common here. So I have 1 plus 1, which is 2. So now to get this guy, I take his top edges. 1 plus 2 is 3. Here, 2 plus 1 is 3. To go here, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Let's see, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. You can see the pattern is symmetrical too. Let's do one more row. So 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 5 plus 10 is 15. 5 plus 1 is 6. All right, so then this first row is your step 0. Then you start to count. So this is like where your home page, right? You start here. Here you are. I'm going to make this into a person. Yay! So then this is step 1, step 2, 3, 4, 5, 6. And that will give you the coefficients of the terms. All right, so let's look. So that's what we were filling in. You can take it further if you wanted to. These are just like little fun puzzles that you can take and fill in. I'm not going to take the time to do that. So what happens here? If I want to do x plus y, my bad, to the power of 4, and I don't want to take the time to multiply it out, I could go to step 4 on my Pascal's triangle, right? So step 4 tells me that the coefficients are going to be 1, 4, 6, 4, 1, right? So they're going to go 1, 4, 6, 4, 1. I feel like I should have written it down here. 1, 4, 6, 4, 1. So then what happens is that first term, I would take him, so x, start him at the degree. So this is going to be x to the power of 4, and then I decline. X to the power of 3, x to the power of 2, x to the power of 1, x to the power of none. Then I take the second term, I start at 0 and work up. So this is y to the power of 0, y to the power of 1, y to the power of 2, y to the power of 3, and y to the power of 4. So these make my terms. So when I clean it up, y to the power of 0 is 1, so I don't need that. I don't need to write a 1. So I have x to the 4th plus 4x cubed y to the 1, we write y, plus 6x squared y squared, plus 4xy cubed, plus, we wouldn't write the 1, x to the power of 0 is 1, we don't need that, so plus y to the 4th. This would be the exact same thing you would get if you took the time to multiply that binomial by itself 4 times. All right, so like x plus 2 to the power of 3, I would go to step 3. So step 3 would be 1, 3, 3, 1. So I've got, oh, there I go with my email again. 1, 3, 3, 1. So I'm going to go 1, 3, 3, 1. So then I start with the first term and the degree. So I go x to the 3 and I descend x to the 2, x to the 1, x, that's a horrible x to the 0. And then I would take the 2, I'd start with 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. All right, so then I'm going to simplify it up. So I've got 1 x to the 3rd, 2 to the 0 is 1. So we have x to the 3rd plus 3, 2 to the 1st is 2. So 3 times 2 is 6x squared plus 2 squared is 4. 3 times 4 would be 12x plus 1 does nothing. X to the 0 is 1 does nothing. 2 to the 3rd is 8. So this would be the same thing you would get if you took the time to multiply the binomials out. All right, so it is called the binomial theorem. It is a shortcut. All right, so now we have x minus y to the power of 5. And if you go back and you notice, right, these are always plus, right? So we have to consider that to be a negative y. Also, I'm going to start doing these vertically. It helps my brain as the problems get more complicated. So this is power of 5. So I would go to step 5. Looking at step 5, I can see that the coefficients go 1, 5, 10, 10, 5, 1. Like I said, I'm going to go vertical. 1, 5, 10, 10, 5, 1. So then I start with the first term x to the power of 5. I'm going x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, x to the none. Now I'm going to have negative y, because you have to take the sign. So it's negative y to the 0, negative y to the 1, negative y to the 2, negative y to the 3, negative y to the 4, and negative y to the 5. So I know I don't need ones, right? They're not going to do anything. Anything to the power of 0 is 1, so that doesn't do anything. Any exponent of 1, we typically do not write. So then I have to figure out, if I'm going to do negative y times negative y, that's going to give me a positive y squared, right? That would be y squared, because a negative times a negative. If I have negative y to the 3rd, a negative times a negative times a negative is going to give me a negative y cubed, right? That's going to end up being negative. Negative y to the 4th would be just y to the 4th, because 4 negatives would be positive. And negative y to the 5th would be negative y to the 5th. So if you notice, if you're squaring a negative number, anytime you take it to an even power, it's going to end up being positive. Anytime you take it to an odd power, it's going to end up being negative. So then I can see my first term here, I've got x to the 5th. So then 5 times negative, right? This is like a negative 1. I'm going to go minus 5, x to the 4th, y. So now I'm at 10. This is, I don't like that I made those minuses because then they look negative. So then this is 10 is staying positive, so plus 10 x cubed y squared. So then I've got 10 times negative, so I got negative 10 x squared y cubed. I'm going to have to continue down here. Then I've got 5, so I've got plus 5 x y to the 4th. And then I finish out with a minus y to the 5th. So basically, you can see if it's a minus, you're going to end up going every other term. Plus, minus, plus, minus, plus, minus. All right, 10, we have x minus 3 to the power of 4. So I can look and see, if you don't remember, 4th would be 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So it goes 1, 4, 6, 4, 1. First term is x, so I go x to the 4th, x to the 3rd, x to the 2, x to the 1, x to the none. The second term is negative 3, right? So I have negative 3 to the power of 0, negative 3 to the power of 1, negative 3 to the power of 2, negative 3 to the power of 3, and negative 3 to the power of 4. So I'm going to clean up some of those numbers there, right? Negative 3 to the 0 is 1, so I don't need him. Negative 3 to the first is just going to be negative 3. Negative 3 squared is 9. Negative 3 to the third is negative 27. And negative 3 to the fourth would be a 1. So now I can see to get my first term, I have 1 does nothing times x to the fourth. So I've got x to the fourth. 4 times negative 3 is minus 12 x to the third. 6 times 9 is going to be 54 x squared. 4 times negative 27 is going to be negative 108 x. And then 1 does nothing, x to the 0 does nothing, so plus 81. Example 5, and this is one where you'll see I really like the vertical method. So power of 4, just like power of 4 last time, was 1, 4, 6, 4, 1. I'm going 1, 4, 6, 4, 1. The first term is x. I go x4, x to the third, x squared, x to the 1, x to the none. Right? So x to the 0 is 1. We don't need that. We typically don't write power of 1. We can get rid of our multiply by 1s if we want to after we write them. We've got 2y. So I'm starting off with 2y to the power of 0, which isn't going to do anything. Right? 2y to the power of 1 is 2y. 2y to the power of 2 would be 4y squared. 2y times 2y. 2y to the power of 3 would be 8y cubed, and then 2y to the power of 4 would be 16y to the fourth. So then to get my terms, first term is x to the fourth. Second term, 4 times 2 would be plus 8 x cubed y. Third term, 6 times 4 would be 24 x squared y squared. Next term, 4 times 8 would be plus, continue down here, 32 xy cubed. And then our last term, all we got there is the plus 16y to the fourth. All right, let's check out one more. We got power of 3. So if you look back, power of 3, step 1, 2, 3 goes 1, 3, 3, 1. So this one's definitely going to be more difficult. 1, 3, 3, 1. Because our first term is 2x. So I have to do 2x to the power of 3. 2x to the power of 2. 2x to the power of 1. And then 2x to the power of none. Right, I'm going to go ahead and rewrite the second term. So then I have negative 5 to the power of 0. Negative 5 to the power of 1. Negative 5 to the power of 2. And negative 5 to the power of 3. All right, let's see what we've got. So 1 doesn't do anything, right? 2x quantity to the power of 3 would be 8x to the third. And power of 0 on the 5, negative 5 doesn't do anything. So first term is 8x to the third. Second term, 2x squared is going to be 4x squared, right? 2 times 2. So 3 times negative 5 to the first is negative 5. So 3 times negative 5 is negative 15. Times 4 would be negative 60x squared. So then I've got 2x to the first is just 2x. But negative 5 times negative 5 is 25. So 3 times 2x is 6x. Times 25 would be positive 150x. And then lastly, let's see, 1 doesn't do anything, power of 0 doesn't do anything, negative 5 to the power of 3, negative 5 times negative 5 is 25, times another negative 5 is negative 125. So this is called the binomial theorem. It's kind of just like a fun little game, in my opinion, that can multiply binomials together. It's also the end of chapter 5.